Okay, so now we're going to take a look at chapter 16. And you see in question number 1 for chapter 16, you have a probability model where you have one random variable defined. In this case, it's a discrete random variable because there's a finite number of outcomes, in this case 4. And it says to find the expected value in the standard deviation. Occasionally, they'll tell you to find the expected value in the variance. So I'm going to take a look at my formula sheet. I need to know these formulas are here. This is the expected value of a random variable. It's the summation of each individual outcome times its corresponding probability. So what I'm going to do is I've already identified the random variable, or the problem has, so I don't need to define it. And I have the expected value of x is equal to the outcome 100 times its corresponding probability 0.1 plus the next outcome 200 times its probability 0.2 plus the next outcome times its corresponding probability plus the final outcome times its corresponding probability. I'm going to come back to that in just a minute. I'm going to show you on the calculator how to calculate that to save us some time. Now for the standard deviation, I'm going to do the same thing. I have standard deviation of this random variable x, looking at our formula sheet here. Now, I need to be very careful. This is variance. So what I'm going to need to do is you're going to notice me putting a square root over this. It's still going to be the summation of each outcome, now minus the mean squared times the probability. So before I can go any further, I'm going to actually need to calculate that mean in my calculator. And I could do that by hand, and I'm going to show you a shortcut right now. So what I can do is I can go to list, edit, and I can put the outcomes in list 1, 100, 200, 300, and 400. And in list 2, I'm going to put the corresponding probabilities, 0.1, 0.2, 0.5, and 0.2. Okay, so now what I want to do is I want to go to stat, calculate. I want to do one variable statistics on L1, L2. So this is a shortcut. The mean, x bar, is going to be 280. So that's going to be 280. And I'm just going to put money earned. So I'm talking about quantitative data. I need units, $280. So standard deviation, going back to the formula here, your variance is the summation of each outcome minus the mean squared times the corresponding probability. So because it was variance and I need the standard deviation, I'm going to be taking the square root here. So it's going to be the outcome 100 minus the standard deviation, or I'm sorry, minus the mean, which we calculated to be 280, squared, times the probability, 0.1, plus the next outcome, 200, minus the mean, 280 squared, times the corresponding probability, plus, I'm going to continue on over here, the next outcome, which was 300 minus the mean, 280 squared, times that probability, which was 0.5. This is the continuation of the square root here, plus the last outcome, 400 minus the outcome, 400 minus the mean squared, times that corresponding probability, which is 0.2. So I really don't want to have to take the time during the AP exam on a free response question to type this in. So going back to the calculator, this is the benefit of it. I have that standard deviation right here. I don't need to calculate that. It's 87.178. Since we're talking about dollars and cents, 87.18. 87.18. So $87.18 is my standard deviation. So that's how you find the mean and standard deviation from a probability model for a discrete random variable. Okay, taking a look at question number 2 now. Given independent random variables with means and standard deviations as follows. Okay, we want to find the mean and standard deviation of each of these. Okay, the key thing here, this is a huge concept here. Independent random variables. This is going back to chapter 16, obviously, in our textbook, where they talk about the Pythagorean theorem of statistics. And we're going to start talking about that once we get to the standard deviation in a minute. So what I want to do is calculate the mean and the standard deviation for part A and or part G and part H, I guess. I need to understand that these subscripts each represent independent random variables. I think one of the examples I used in class was X might be the time it takes you to get ready to get to school. So this might be the time that it took Monday, Tuesday, and Wednesday, which is different than just 2 times Y. That might be 2 times the time that it took you to get ready one specific day. So as I'm calculating my expected value, it's going to be expected value of that. I can also use mu sub x1 plus x2 plus x3 minus 2y. I know that's a little bit smaller. Either way, I can calculate it. And I'm literally, for expected value, I'm going to do exactly what it says. So in this scenario, I'm going to just add. So for the expected value here, for the variable x, it has a mean of 40. So I have 40 plus 40 plus 40 minus 2 times the expected value of y, so minus 2 times 37. And that's going to give me 46. So my answer here is 46 units. Okay. I need to calculate the standard deviation next. So I'm going to have standard deviation of x sub 1 plus x sub 2 plus x sub 3 minus 2y. Or I could write it as sigma sub x sub 1 plus x sub 2 plus x sub 3 minus 2y. Either notation is appropriate. In either case, when I'm calculating this is going back to this whole idea of the Pythagorean theorem of statistics and this idea of I am having independent random variables. In order to do this calculation, I need to add the variances. So what this is going to entail is going to be, if I'm given the standard deviation and I want the variance, I need to square these. I can choose to create a separate column and square that. And square that. 6 squared is 36. 8 squared is 64. Those would be the variances. So I'm adding the variance. So really what I'm doing here is I'm taking 6 squared, that's the variance of this random variable, plus 6 squared, that's the variance of this random variable, plus another 6 squared. I'm always adding variation. The question that I used in class was the water bottle. When Mr. Coe was throwing the water bottle, and I was trying to say when you pour more water out, there's more variability. So this is plus, and it's going to be 2 squared times 8 squared. The reason it's 2 squared, if I was just calculating, say, the standard deviation of 4x, I would need to do 4 times whatever that standard deviation was. But now that I'm talking about the variance and it's under the square root, in order for that square root to be 4, I need to square it. Okay, so that's going to be my calculation for the standard deviation. When I calculate that out, I'm going to get 19.1 units. And I've rounded that a little bit, but 19.1 units. So that's how I calculate the mean and the standard deviation for part G. Let's take a look at part H. Okay, in part H, it's going to be very similar. I have the expected value of 50 plus 3x minus 2y. 50, when I add and subtract from the mean, if the mean of a set of data is 60 and I add 10 points to every, say it's a test score, that mean now becomes 70. So adding and subtracting affects measures of center, plus 3 times the expected value of x, which was 40, minus 2 times the expected value of y, which was 37. And let me move that over. So that's going to give me an expected value of 96 units. Okay, for standard deviation of 50 plus 3x minus 2y. Again, I need to have good notation, that or sigma sub this. Now what I need to think about, adding and subtracting does not affect measures of spread. If you take a look at this here, if I have that for a range, and this is 10 and this is 30, and I add 100 points to everything, this is now 110 and 130. The spread, the variability did not change. So adding and subtracting does not affect measures of spread. And what I mean by that are range, IQR, standard deviation. So I'm not going to include this 50. I do have independent random variables, x and y, so I still need to add the variances. So I'm going to need to do 3 squared times the variance of x, which is 6 squared, plus always adding variances, regardless of if you're adding or subtracting. 2 squared times the variance of y, which is 8 squared. And this is going to give me 24.1 units. Okay? If this is a question on the AP, you're not going to see it like this. It's going to have some context to it, x being something specific and y being something specific, but then has to apply these concepts to that question. Okay, question number 3. And this kind of gets into what I was just saying. All right. So take a look at the question. It says the amount of cereal that can be poured into a small bowl varies with a mean of 1 ounce and 1.5 ounces and a standard deviation of 0.3 ounces. A large bowl holds a mean of 2.5 ounces, standard deviation of 0.4. So we're pouring out 1 large bowl and 1 small bowl of cereal here. So I really have 2 random variables. I have to make the assumption, I have to assume the variables are independent. In almost every single short answer or multiple choice question I've seen on the AP, it always says they're independent, or they assume that they were independent. And that's a huge hint that it's going to be something dealing with random variables. Okay, so I need to define 2 random variables. I have cereal that I poured into a large bowl and a small bowl. If this is a free response question, I need to define them. L can't just be large. That has no context to it. So it's the amount of cereal in the large bowl, and S can be the amount of cereal in the small bowl. Pick variables are going to make sense for the question that you're working on. That makes sense. Okay, how much more do you expect to be in the large bowl? So expect, we're talking about expected value here. I have my 2 random variables, expected value of the large minus the small. Well, the expected value, the mean for the large and the mean for the small. Large was 2.5 ounces minus the expected value of the small bowl was 1.5 ounces. So my difference is 1 ounce. What's the standard deviation of this difference? So now I have the standard deviation of L minus S. I have 2 independent random variables. I have to add their variances. So now I'm looking at the standard deviation for the small bowl was 0.3. For the large bowl was 0.4. So I have 0.4 squared plus 0.3 squared. And that gives me a standard deviation of 0.5 ounces. So the mean is 1 ounce. The standard deviation is half of an ounce. All right, so let's take a look at the next page. And this question continues on here. Okay, this is a nice follow-up question that you're going to possibly see on the AP exam. And they like to tell you this, if the difference follows a normal model. So essentially that's really important because we just calculated the mean and standard deviation. We know that the normal model has 2 parameters, mean and standard deviation. Mean mu, standard deviation sigma. So I know that the mean is 1 ounce and the standard deviation is half an ounce. And I want to know what's the probability the small bowl contains more than the large bowl. Well, I need to think about this. This is not very easy. So we did large minus small. Well, think about when they would have the same amount of cereal. If they had the same exact amount of cereal, this difference would be 0. So that's going to be my statistic. So I have a normal model here. The mean is 1. The standard deviation is 0.5. The statistic is going to be 0. That's when they would be equal. So if I want to know when the small bowl contains more, if this number is bigger, when I subtract a small number minus a bigger number, I'm going to get a negative. So I'm going to be shading a lower tail here to represent that area. Okay? I know a mean, I know a standard deviation. I'm going to calculate a z-score here. My statistic is 0 minus my mean of 1 over my standard deviation of 0.5. Because my statistic is below my mean, I should be getting a negative z-score. In this case, I do. I need to know the probability z is less than -2. So on my calculator, I'm going to go to norm CDF, -999, comma, -2. And we're looking a little over 2%, so 0.023 it looks like. 0.023. So a little over a 2% chance that the small bowl is going to end up with more cereal in it than the large bowl. So, chapter 16, questions that deal with random variables. Given a discrete random variable probability model, calculate the mean, calculate the expected value, or calculate the standard deviation, and then being able to deal with independent random variables in a word problem like we just did. Next, we'll take a look at chapter 17.